All right, today's notes are going to be on Module 9, Lesson 2, Pythagorean Theorem and its Converse. So we already have learned Pythagorean Theorem. Today we're just going to learn the Converse, but we're also going to do a lot of Pythagorean Theorem review. All right? And so again, this is very, very important. Take the time. If you do not know Pythagorean Theorem, it is top 5 most important things in geometry class this year. A squared plus B squared equals C squared is the theorem. It has to be a right triangle. So this theorem works with right triangles. And so as soon as you see it's got a right angle, you have to know which side is C. And the way I remember that, and we've talked about this, is that the right angle points at C. And so C is the hypotenuse, it's the longest side. And it doesn't really matter which of the other sides is A or B, and A or B, as long as you know which side is C. And then you're going to do, A or B squared plus A or B squared equals C squared. And so first thing you always have to figure out is which side is C. Again here, this side down here has to be C. And so I'm going to do 7 squared plus 17 squared equals x squared. Again, could have done 17 first. Doesn't matter in that way. But C has to be that x. And so 7 squared is 49. 17 squared, take your calculator, it's going to tell you 289 equals x squared. Those add up to 338. Now, how do you solve it? How do you get rid of that squared? What's the opposite of something squared? Commonly people say divide, and it's kind of like division, but it's a different button on your calculator. You're thinking, what number times itself makes 338? And so I have to undo the squared by doing the square root. And so I get 18.38, yada, yada, yada. And so anytime we're rounding and it doesn't tell us what to round to, we're going to round to the nearest hundredth, which is 2 decimal places. Go ahead and give this one a try. I'll pause the video right here and give this one a try. Now, as you're trying, please note this side over here is still pointing to the C here. And so y squared or 12 squared has to be first. 13 squared has to be last. Hopefully that helps you. Again, pause the video, give it a try. All right, hopefully you set that up. 12 squared is 144, 13 squared is 169. You subtract the 144 over, then you throw that square root into it, and you get y equals 5. Hopefully you were able to successfully do that as well. Okay. Now, this slide is either super awesome or super unimportant, depending on how you want to view your math ability. All right. These are a Pythagorean triple. So these numbers work all the time. The ones in bold black right here. All right. Really looking at this row. And so they're the most commonly used sets because we know they work. We know they make perfect right triangles. And so if you think about like problems on a test or problems in your homework, or, if you really get into the construction business, you want to have, guaranteed accuracy. All right. But just for as far as like on an SAT or ACT, they're most likely to use these sets. So like if it says 3, 4, and then what's the missing side? Well, it's a right triangle. You know the missing side's 5. Or the multiples of those. So these are just all multiples of 3, 4, and 5. All right. So 3 times 5 is 15. 4 times 5 is 20. So if it said 15, 20, you know the missing side would be 25. Right? Same thing here, 5, 12, 13. Those will always make a right triangle. 8, 15, 17, 7, 24. There's others, all right, but those are the most commonly used ones. And, you can memorize them, 3, 4, 5, especially if you can memorize that, it kind of helps you as a time save, kind of makes your life a little bit easier. But you don't have to because a squared plus b squared equals c squared will always work. And so it's just a time save. It's just a way to feel like you are smarter than the average bear when you're doing a problem. All right, let's look at an example. All right. Again, it's a right triangle. So what is this side? Well, I notice right away 15 and 12 are both multiples of 3. And so if it was a 3, 4, 5 triangle, all right, 3 times 4 would make 12, 3 times 15, 3 times 5 rather would make 15, 3 times 3 would make 9. And so x equals 9. And so I know that without having to do any math because I know 3, 4, 5 works. If I want to do the math, I would just do what I did down here. I would still get 9, no harm, no foul. So you can do it either way. Okay. All right, this unit is going to have lots of little story problems, and they're not going to give us a whole lot of misleading information, which is good. So we just got to figure out what they're asking. So a summer camp is building a new zip lining course. The designer of the course wants the last zip line to start at a platform 450 meters away from or above the ground and end 775 meters away from the base. How long must the zip line be? All right, let's think this through here. So you got 450 up into the sky and 775 away. And we want the zip line to go down here. And that's what I'm trying to find. And so which side has to be the C? It's a right triangle because of the pole. We can assume all these problems are right triangles because we can always assume they build it with the platform or you standing or whatever straight up from the ground. All right, so it's a right angle. It's a right triangle. And so this side over here has to be C. And so I'm going to do C 450 squared plus 775 squared equals x squared. Grab my calculator, 450 squared. I do not know that one until I type into the calculator at 202,500. 775 squared. Calculator says 600,625 still equals x squared. Those two add up to 803,125. Now, am I done? Is that the answer? No, I have to get rid of the squared. To get rid of the squared, I have to do the square root. And so my answer is the zip line must be a little more than 896 feet away, 896.17 meters. All right. If you just said 896 in the test, I would probably be okay with it. All right. So the converse is the reverse. So before it was, if it's a right triangle, has to be a right triangle, then I can use a squared plus b squared equals c squared. So the reverse is, if you don't know, if they just give you numbers and you're not sure if it's a right triangle or not, if a squared plus b squared equals c squared works, then it's a right triangle. And so your problem is going to be like this. They're just going to give you the numbers, 3, 4, 5, we'll say. Is it a right triangle? And 3 squared plus 4 squared would have to equal 5 squared. Now, how do I know 5 was C? There's no picture here. Remember, C is the hypotenuse, which means it's the longest side. So the biggest number is always the C. And so that would be 9 plus 16 equals 25. And so 25 equals 25. And so it worked out. A squared plus B squared did equal C squared. So it's a right triangle. Also, though, you can see if it's not true. So if you get a problem like, 3, 4, 6, obviously then you have 9 plus 16 equals 36, which is 25 equals 36, which is not true. That's not true. Right? 36 is bigger. C squared is bigger. Down here, I show you, I still like to think it through like a squared plus b squared equals c squared. So I don't like to think it through like they say. All right. But at the end, I am thinking what they're thinking. Is c squared bigger or smaller? And in this case, c squared is bigger. So this one would have been obtuse. 3, 4, 6 makes an obtuse triangle. If when you do it, they're not equal, but the c squared part is smaller, then it's acute. So again, you're just going to still do a squared plus b squared equals c squared, but if it's not equal, then it's either going to be bigger or smaller. And if c squared is smaller, it's acute. If c squared is bigger, then it is obtuse. And so these are what your problems are going to look like. And it's going to say something like justify your answer. Showing the work justifies your answer. And so 5 squared plus 6 squared equals 8 squared. Now, how do I know that 8 is the C? 8 has to be the C because it's the biggest number. And so 25 plus 36 would equal 64, which is 61 equals 64, which is not true. All right, that is not true. So which one's bigger? 64 is bigger. And so that means this is obtuse. Okay. Let's look at part B. All right. Part B, 10 squared plus 24 squared equals 26 squared is 100. 10 squared, hopefully that's easy for you. 24 squared, if you don't know it, grab a calculator. It's 576. 26 squared, if you don't know it, grab a calculator. It's 676. And so I get 676 equals 676. Well, that is true. It worked out just fine. And so this is a right triangle. There's one more to try here. There's C. All right. And so we want to know 4.4 is the C. All right. So a squared plus b squared equals c squared. I did it here on the next page. 2.4 squared plus 3.8 squared equals 4.4 squared. Got 5.76 plus 14.44, right, equals 19.36. Well, they're not equal. These add up to 20.2. 20.2 is bigger. So c squared is smaller. If c squared is smaller, it is acute. On page 517, try those problems. I wish there was more like those last ones we had, but the book didn't give you great examples, so I only gave you 22 to try. But good luck to you, and we'll talk about it tomorrow in class if you're in class.